Now we're going to talk about the actual graphs of sinusoidal functions. We're going to actually have some graphs, and we're going to describe a few things. For example, we're going to talk about the range, midline, amplitude, and period. So the range is the maximum and minimum values within a set notation. The midline is a horizontal line that would cut a graph in half. Amplitude is always going to be measured from the midline to the maximum or the minimum value. And a period is how long it takes in x, so along the x-axis. The period tells us how long something takes to actually repeat. Now, a lot of these things, for those of you that have taken Physical Science 20, will kind of remember when you talked about waves. And that's exactly what a sinusoidal function is. It's a wave. So we have some graphs. We're going to describe this graph by determining range, midline, amplitude, and the period. So first off, the range. The range is the maximum and minimum values written in set notation. So in this case, it's talking about our y values. Our lowest y value here is -3. The highest value is +7. So less than or equal to y, less than or equal to 7, y being an element of the real numbers. Of course, another way of writing our range is using our fancy R. The equation of the midline. So the midline is the horizontal line that would cut this graph directly in half. So where would it cut this range directly in half? Well, it would have to be right here. Because halfway in between -3 and +7 is 2. So y equals 2. The next characteristic is the amplitude. The amplitude is measured from the midline to the maximum or the minimum value. Which means if we measure from our midline and we measure all the way up to its maximum, that is a size of 5. At the same time, if we go from our midline down to our lowest value, we have 1, 2, 3, 4, 5. So our amplitude, we usually notate with an A, and that's going to come in effect in our section 3. The amplitude is 5. And the last bit is the period. It's how long it takes in x for a graph to repeat itself. So how long does it take this graph to actually repeat itself? I'm going to move this extra information out of the way. So if we look at it, there's a few different ways of finding the characteristics. For example, we can measure from the top to the top, because if we go along this line, it goes all the way down. I know it's not following perfect, so you'll have to bear with me a little bit. But it goes all the way back up to the top, and then it repeats itself. It repeats itself. It repeats itself. This one may not be the easiest to see. So another way we can read it is actually from the middle. We can read from the middle. It goes up, back to the middle, but then it goes down and back to the middle. After that, it repeats itself. It repeats itself. It repeats itself over and over. But again, this one may not be the easiest to read either. The reason I'm saying that neither of these ones are the easiest to read is because if we read from where it's beginning, it's not starting directly on a line. So we'd have to do an estimate. Let's see, that's 120, so that would be 60. It might be starting at about 50, but we don't know exactly. So we're going to have to do some other things. Same thing as this one. It looks like it's about halfway in between the 60 and 120, so we can hypothesize and make an approximate that it is 90, but we want to be as accurate and as exact as possible. So we can measure from the top to the top, or from the middle, till it actually repeats itself back at the middle. Or what we can do is we can measure from the bottom to the bottom, which means starting at the bottom, going all the way up to the top, and back down to the bottom is our period, because after that, it repeats itself over and over and over again. So this one for sure can be read, because this one is exactly starting halfway in between 120 and 100 and 240, which works out to be 180. And it looks like it's ending exactly at 360. So how long does it take to repeat itself? Well, the quick calculation is 360 subtract 180. The period is 180 degrees. And there's our start of understanding of what we're talking about when we talk about range, midline, amplitude, and period. So let's do the next one. Our range. Oh, that's domain. Delete that. 1D. There we go. So our range again talks about the maximum and minimum values written in a data in set notation. So maximum, minimum. Well, let's see. The minimum value is -4. And the maximum value is +2. Y, of course, is still a real number. Our midline is what is halfway in between our minimum and our maximum. Well, halfway in between -4 and +2 is -1. So y equals -1 is our midline. Our amplitude, so again, measured from that midline to our highest point. In this one, from -1 all the way up to +2 is not 6, it's 3. Or from our midline down to our minimum value is 3. So our amplitude is 3. And last but not least is our period. Now this one's a little bit trickier because we can't actually see the 3 ways that we usually characterize our period. We don't have 2 crests, 2 tops of these waves, or 2 troughs, the bottoms of the waves. At the same time, we can't see exactly where it does go to go all the way up, down, and back up to the middle. But that's not limiting us, because even though one way we can determine our period is by going all the way back to this middle point, we're not going to approximate this. We're actually going to have it exact. The fantastic thing about it is if this is our entire period, where it goes back to the middle will be exactly half of it. So going from here all the way up and back down to the middle will be half of the period. In this case, that's 2.5. So 2.5 multiplied by 2 is 5. Our period is 5. And that's it. Example 2 says, for a physics project, Morgan and Lily had to graph and analyze an example of simple harmonic motion. Morgan swung on a swing, and Lily used a motion detector. This is sometimes an activity that's done in physics, not always done, depending on availability of materials, but it can be done using motion detector. So what's being done is it's measuring the height of Morgan over time as she swings back and forth. The girls then graph the data as shown. At the end of the cycle, the swing returned to its original, or its initial position, which resulted in this sinusoidal curve, sinusoidal graph. We're going to describe this by determining the range, equation of the midline, amplitude, and period. So our range, again, let's talk about our y's. Our lowest y value, well, this would be about 0.75. Our highest value, see, we have every single square worth a quarter. So 2 squares would be a half, meaning 2.5. Midline. Well, what would split this in half? If you don't want to calculate exactly what half it is, well, we can measure it. We have 1, 2, 3, 4, 5, 6, 7. We have 7 squares, so we'd have to have 3.5. Sorry, I've been using dash lines, sorry. So what's halfway in between? Well, let's see. This would be 1.5. This would be 1.75. So split the difference. We'd be at 1.625. Of course, that's not the only way we could do it. We could also do it by just taking our minimum and adding our maximum. That'd still be 3.25 divided by the 2. Yeah, it's still 1.625. See, our next one is the amplitude. What is our amplitude? How much is it measured to go from the midline to its maximum or the midline to the minimum? Sorry, make that actually look like it's going to the minimum. Well, a quick calculation for it. So I just have to take the 2.5, subtract the 1.625, and our amplitude is 0.875. Now this one actually has a unit for it because our amplitude is a vertical measurement. It says that's being measured in meters. And then our last one is our period. How long it takes to repeat itself. So we look at the different ways. We can measure from the top to the top. We can go from the middle back to the middle. Now in this one, we don't have to necessarily start at the middle, go up, down, and back. We could start at the middle, go down, up, and back down to the middle. Or we could go from the bottom of the trough to the bottom of the trough. It doesn't really matter because I can do it any way, shape, or form. I can measure from the top to the top, from 2 to 4. Well, that's a really quick calculation. This one I would not expect that you would have to do, because you could just exactly read it. It's 2. And because the period is an x measurement on our x-axis, seconds. So if we go further into the actual analysis of this graph, it says that after 2 seconds, who's swinging on the swing? Morgan. Morgan would repeat her swing every 2 seconds. She'd be at the highest height, go down to her lowest height, and back up to her highest height in the span of 2 seconds. The middle value will be 0.875 meters. Her lowest value will be 0.75 meters. So what would be Morgan's height above the ground at 4 seconds? Well, that's a really quick measurement. At 4 seconds, her height is at 2.5 meters. And there's our start of our understanding of what a sinusoidal function is going to look like. So go have some fun.